In this video, we will cover packet filtering firewalls. This is the simplest and oldest form of firewall technology. Understanding how it works, and specifically where it falls short, helps you understand why stateful inspection and next-generation firewalls were developed, and why you need to know which type of firewall is in a given location in your OT network. A packet filtering firewall examines each packet individually, looking only at the packet's header fields. The header contains the metadata about the packet, where it came from, where it's going, what protocol it's using, and what port it's targeting. Specifically, a packet filter checks the source IP address, the destination IP address, the source port, the destination port, and the protocol, TCP, UDP, ICMP, so forth. Rules are configured as a list, evaluated in order from top to bottom. When a packet arrives, the firewall compares it against each rule in a sequence. The first rule that matches determines the action, permit or deny. If no rule matches, the firewall applies a default action, which is either permit or deny, based on configuration. Because the evaluation is based only on header fields and doesn't require deep inspection of the packet's content, packet filtering operates at a very high speed with minimal processing overhead. This makes it well suited for embedded devices with limited processing power. Packet filtering has real advantages that explain why it persists in OT environments: speed and simplicity. Because it only reads the packet headers, not the payload content, it can process traffic at wire speed on minimal hardware. This makes it practical for embedded industrial routers, access control lists on managed switches, and legacy OT network equipment that doesn't have the processing power for more complex inspection. To clarify, a packet filter rule is straightforward to read and audit. As an example, permit TCP from 10.10.1.0/24 to 10.20.1.50 port 502 means exactly what it says. There's no guesswork there. It goes directly to that host, to that port. Packet filtering is supported on virtually every managed switch and router, including the Cisco iOS access control lists, or ACLs, that appear on most industrial network infrastructure. Even where a dedicated firewall appliance doesn't exist, packet filtering may be available in the existing infrastructure. The fundamental limitation of packet filtering is that it evaluates each packet independently, with no awareness of the connection or session it belongs to. So that's why it's called stateless evaluation. A packet filter doesn't know whether an inbound packet is part of an established, legitimate session that was initiated by an authorized source, or if it's an unsolicited probe from an attacker. It checks the header. If the header matches a permit rule, the packet is allowed through, regardless of context. This creates an exploitable gap. An attacker crafting packets with header values that match a permit rule can pass through a packet filter, even if those packets are part of an attack, rather than a legitimate session. Certain attack techniques, like crafting TCP packets with specific flag combinations, can actually exploit this blind spot. The second limitation is that packet filtering has no visibility into those packet payloads, the actual content of the communication. It just identifies traffic by port number and IP address, not by what the application is actually doing. So traffic arriving on port 502 is assumed to be Modbus. Traffic arriving on port 80 is assumed to be HTTP. If an application uses a non-standard port, or if malicious traffic is encapsulated inside a permitted protocol, a packet filter doesn't detect it. You'll find packet filtering in several specific places in OT environments. Access control lists on Cisco routers and managed switches. These are packet filters implemented into the router switch software applied to specific interfaces. They're very common in OT infrastructure because Cisco equipment is widely deployed and ACLs don't require additional hardware. Embedded industrial routers and protocol gateways will also have packet filtering software. Many of these devices have this as their only firewall capability. The hardware can't support stateful inspection, but it can evaluate header fields. Some legacy OT network perimeters that were designed a decade or more ago with packet filtering as their primary boundary control. They still may be running that configuration even as the threat environment has changed significantly. When you encounter packet filtering as a primary boundary control between OT zones, it's worth assessing whether the rules are specific enough to compensate for stateless limitation, and whether there are additional controls, monitoring, detection, that offset what packet filtering alone can't catch. In the next video, we'll cover stateful inspection, which addresses the session blindness problem and is the standard approach in most modern firewalls.